Okay, we're going to do the next part here. The next question is, prove giving all reasons that TK, that's T out there, TK bisects this angle AKB. So bisects means that these two angles would be exactly the same. You could cut them in half. So that this line cuts them in half, they're really asking us to prove that K2 is equal to X. Well, we've got two things we got something else we've got to do first. We have to remember that we just proved that AKBT is a cyclic quad. We might probably have to use that. And we've been given two tangents, and tangents from the same point, they're equal. So this angle A3 must equal this angle B1. Ooh, that's important. Because of tangents from the same point. So that's how you'd say B1 equals A3, which equals X, um, because of tangents from the same point. Now we've got this as X. But we just proved in the last question that A, K, B, T, there's a T out there, that that's a cyclic quad. Well, if it's a cyclic quad, then this angle here, B1, opens up to AT. Well, so does K2. K2 must equal B1 because of angles in a cyclic, because of angles in the same segment in a cyclic quadrilateral. Angles in the same segment, AT. Okay, so that's it. We just proved that K2 equals K3, which is X. We just proved that TK bisects, cuts angle AKB into two equal things because we just proved they're both equal to X. Okay, the last question. The last question says, prove, prove that TA is a tangent to the circle passing through A, K, and H. Well, you look at this A, K, and H, we could put a circle around A, K, and H, because this angle here, um, oh, A, K, and H, there it is, A, K, and H. You could put a circle through A, K, and H right there. Oh, I was looking at the wrong place. A, K, and H. We could put a small circle through there. And why? Because the angle between the tangent and this chord here, AH, it'll be a chord in the circle, is equal to the angle at the top of the triangle. So it's the converse of the tan chord theorem that makes that work. Okay, so let's see what that would look like. Um, you would just write down TA is tangent to the circle passing through A, K, and H because of the tan chord theorem. And the last question, remember we said B1 is X because of tans from the same point. K2 is X, angles from the same segment. So and because we proved in the last question, AKB is a cyclic quad, and then we should write, actually, therefore, then we would have to write next here, therefore, then we could write therefore what? Therefore, that line there, TK bisects AKB. That's what we were supposed to prove, that it bisects. Therefore, TK, I think it is, TK bisects AKB. Therefore, therefore, TK, TK bisects AKB. That's what we were trying to prove. So I think you'd have to say it. TK cuts AKB into two equal pieces of X because we've showed they were both X. So that's it. Therefore, TK bisects AKB. That's how you would write it out. And we know that TA is tangent to the circle going through these points because of the tan chord theorem, the converse of the tan chord theorem. Okay, hope that helps.